This is a 3-minute review of Kepler's laws related to gravitation. Like the Earth rotating around the Sun, with the Sun as a focus in an elliptical path. And then at the ends of the ellipse, we have a slow velocity of the Earth in the summertime when it's far from the Sun, and a faster velocity of the Earth in the wintertime when it's near the Sun. And the Kepler's says that the Earth's path carves out equal areas in equal time. So the blue space shown above is always equal, and it goes slow when it's far from the Sun and fast when the Earth is close to the Sun. The green arrow is the Earth's velocity, which you can see decreasing and now increasing as it gets closer. Of course, the Earth's orbit is almost a circle. This is exaggerated to show the effect, but all orbits of our planetary bodies are ellipses. And ellipses have major and minor axes, and they have two foci. Well, the third law of Kepler is that the square of the period, how long it takes to go all the way around, is proportional to the major axis of the ellipse cubed. The period squared is proportional to the major axis cubed. And we use astronomical units for the Earth, where that's 93.5 million miles from the Sun. And so the period squared of the Earth is equal to the AU's cubed. And if we were to look at Earth and Mars as a comparison, with the AU equal 1 for the Earth, or 93 million miles, we can see that Mars is 1.524 astronomical units. So if we take the square root of 1.524 cubed, we'll get 1.88 Earth years, or 687 Earth days. So to recap, the Earth has its fastest velocity in the winter when it's closest to the Sun, and its slowest velocity in the summer when the Earth is farthest from the Sun. And so the tilt of the Earth is what gives us our seasons, and the ratio of velocities at apogee and perigee depend on the relationship between the major and the minor axis. So 1 AU, an astronomical unit, is about 93 million miles from the Earth. Now you can replace the Sun with the Earth and the planet here with a satellite, and you're going to get the same type of orbit, except that you can compute the velocities with this formula where the GM is given as shown, and this formula will give you the velocity in meters per second if you use that value for GM. And you'll get the same relationship that you had before. Good luck.